A system is shown in the figure. The bar AB is assumed to be rigid and weightless. The natural frequency of vibration of the system is given by. We have a weightless rigid bar pivoted at its left end. Two vertical springs are attached to this bar. Spring K1 is connected at a distance A from the pivot. Spring K2 is connected at L from pivot. To find the natural frequency of the system, problem divided into two parts. Fixed bar and spring connected at a distance A is part 1. Hanging spring mass is part 2. Redrawn part 1 with bar and spring having stiffness K1 hinge at distance A from pivot, and part 2 replaced with force F at free end. Find equivalent stiffness KE1 by assuming small deflection delta at force end. If delta is the deflection at force end, then X1 is the deflection at spring support. X1 replace with delta terms. Applied equilibrium method, moment at fixed end. Force into length L equals spring force into distance A. Spring force is equal K1 into X1. Replace X1 with delta terms, so X1 equal delta into A divided by L. Now, F equals K1 into delta into A by L again into A by L. Finally, F equals K1 into delta into A by L whole square. Equivalent stiffness KE1 equals force F divided by deflection delta. Now, KE1 equals K1 into A by L whole square. Now part 1, equivalent stiffness KE1 connected in series with the part 2 and draw free body diagram. Find total equivalent stiffness. Total equivalent stiffness is part 1 plus part 2. In this KE1, we already calculated springs are in series. Equivalent stiffness will be calculated by 1 by K total. Equivalent stiffness equals 1 by KE1 plus 1 by K2. Now replace KE1 with K1 terms. KE1 equals K1 into A by L whole square. By substituting KE1 in total equivalent stiffness equation, we will get 1 by K total equals 1 by K1 into A by L whole square plus 1 by K2. By solving, 1 by K total equals K2 plus K1 into A by L whole square divided by K1, K2, A by L whole square. Finally, K total equals K1 into K2 into A by L whole square divided by K2 plus K1 A by L whole square. Frequency Fn equals 1 by 2 pi into square root of K total equivalent stiffness by mass. By substitute K total equivalent stiffness Fn, we will get 1 by 2 pi square root of K1 into K2 into A by L whole square divided by M into K2 plus K1 into A by L whole square.